In this video, we'll give you an example of a closed and an open loop DDC control system. The use of open and closed loops is found throughout sequences of operation for most building control strategies. Closed loop control of air handler unit discharge air temperature. In HVAC systems, a closed loop control system using a discharge air temperature sensor and a control valve controlling the flow of hot or chilled water is employed to maintain a consistent supply air temperature from a coil. Here's how it generally works. A discharge air temperature sensor is placed in the air stream after the heating or cooling coil. Its purpose is to measure the temperature of the air leaving the coil, which is known as the discharge air temperature. The discharge air temperature is sent to a controller in the form of an analog input. The controller compares the actual discharge air temperature to the desired set point temperature. The controller sends an output signal to the coil control valve, which is responsible for regulating the flow of heating hot water or chilled water through the coil. The control valve is positioned by the controller based on the comparison between the actual and desired discharge air temperatures. If the actual discharge air temperature is higher than the set point, it indicates that more cooling is needed. The controller signals the control valve to open, allowing more chilled water to flow through the coil. If the actual discharge air temperature is lower than the set point, it suggests that the space is adequately cooled. The controller instructs the chilled water control valve to close or reduce the flow, reducing the cooling effect. The heating hot water responds in a similar manner. This entire process forms a closed loop system. The controller continuously receives feedback from the discharge air temperature sensor and adjusts the coil control valve to maintain the desired discharge air temperature. Benefits: energy efficiency. By precisely controlling the coil operation, the system optimizes energy consumption. Comfort. Consistent discharge air temperature ensures a comfortable environment for occupants. In summary, a closed loop system using a discharge air temperature sensor and a coil control valve allows for real-time adjustments to maintain a stable and desired supply air temperature from the cooling coil or heating coil in an HVAC system. Open loop system for heating hot water temperature reset. In an open loop control system using an outside air temperature sensor and a three-way heating hot water control valve, the goal is to reset the hot water set point of a boiler based on the outside air temperature. Here's a breakdown of how this system typically operates. An outside air temperature sensor is located outdoors to measure the ambient temperature. The information gathered by the outside air temperature sensor is crucial for determining the heating requirements based on the actual outdoor temperature conditions. The outside air temperature from the sensor is sent as an analog input to the boiler's controller. The controller analyzes the outside air temperature and compares this to the heating hot water temperature reset schedule programmed into the controller before deciding on whether to adjust the set point temperature. The controller lowers the hot water supply temperature set point as the outside air temperature increases. When the outside air temperature gets colder, the boiler controller increases the heating hot water supply temperature set point. Using a closed loop control sequence, the hot water temperature sensor sends an analog input signal to the boiler's controller indicating the current temperature of the heating hot water. The boiler's controller will compare the reset schedule with the current hot water temperature and send an analog output signal to adjust the three-way valve to either increase or decrease the flow based on the current water temperature. The three-way control valve is responsible for controlling the flow of hot water in the heating system based on the analog output signal from the controller. It has 3 ports and can direct the flow in different ways based on the control signal it receives. As the outside air temperature changes, the controller adjusts the set point temperature of the boiler, and if required, will send a signal to the three-way hot water control valve to meet the current demand. This adjustment is based on the heating hot water reset schedule. When the outside temperature is lower, indicating colder weather, the controller will adjust the boiler supply water temperature upwards based on the reset schedule, and then instruct the three-way valve to allow more hot water to flow into the system, increasing the temperature of the heating medium. Conversely, in milder weather, the controller may adjust the three-way valve to allow less hot water into the system, thereby reducing the temperature of the heating medium. Benefits: energy efficiency. By resetting the hot water set point based on outside conditions, the system optimizes energy usage by providing only the necessary amount of heat. Weather adaptation. The system can automatically respond to changes in external temperature, ensuring efficient heating in various weather conditions. In summary, an open-loop system using an outside air temperature sensor and a three-way hot water control valve allows for real-time adjustments of the hot water set point of a boiler based on external temperature conditions. This approach helps optimize energy consumption and provides effective heating in response to changing weather patterns. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.